Although Mars is considered the most habitable planet in the solar system, it's still extremely hostile for human life. The main difference is, to start with, the pressure. The pressure is 100th of the Earth's atmospheric pressure, so you would literally, your liquids inside of your body, water, blood, anything, would vaporize. And the other thing is extreme temperatures, like extreme cold. The other environmental hazard would be the fact that it's just a very high UV environment. You have basically no atmosphere. The atmosphere is very, very tenuous, so you would have to be protected against UV radiation. And of course, the other one, which is my research, is high energy radiation. Well, Utah was chosen mainly because if you go there, it looks like Mars. It's unbelievably Martian. The location of the habitat, it's really right in the middle of nowhere. I mean, we were about an hour away from the nearest outpost of civilization, which was a gas station, a little motel, and that's it. We were living inside the habitat, and the habitat is a cylindrical two-story structure, about 8 meters in diameter. And then in the first floor, you have the living quarters. Each of the crew members had their own private living quarters. It was very tiny, but it was not bad. Then we had a kitchen and a common living area, so we would always have dinner together and lunch. We made that a priority. We had salads, and the salad was from the green hub. We had lettuce and carrots and radishes, some little tomatoes. We ate very well, I have to say that, and that's a very important psychological factor, to be able to eat well. In the first floor, there is all sorts of experimental areas, such as engineering and geology and biology and all these things. You also have 2 different spaces that are simulating airlocks. So every time you have to get out, you have to simulate some depressurizing. So that means when you put on your suit, then you have to breathe, like in the real space missions, you have to pre-breathe some oxygen to get your body accustomed to the new pressure and the new composition of your air inside your spacesuit. And then once that pre-breathing has been finished, then that's when you can open your airlock and actually walk outside into space. These are the suits that we were using to simulate. They're not real pressurized suits, but they simulate some of the weight and some of the mobility aspects of it. And we have the radios connected to our helmets, so we can be talking to each other and also to the habitat. In our backpacks, we have an air cooling system, so it runs through our helmets, and it prevents our helmets to be fogged up. So we have the backpacks, and we have the boots, and we have the suits that are themselves pretty heavy. Not too heavy, but they're about something like 30 pounds, which is kind of equivalent to what you would experience on Mars. So maybe a little bit heavier, but you have a third of the gravity there. So it was simulating a little bit the mobility experience. So this is the NXD-1 prototype of NASA spacesuit. This is a very new design. It's called a planetary spacesuit, but is tailored for Mars. It's pressurized. If I show you footage, you'll see that it's spectacular. I mean, the person inside can bend, can do anything they want. It's super comfortable. The hands are able to pick up anything, and it's very incredible mobility in the fingers, which is very important too. The other thing was, maybe a crew member breaks a leg, then we have to get out with a stretcher, put him or her in a stretcher, and bring them back. We developed a special stretcher that had room for the backpack, because of course as an astronaut you would have a backpack and you can't take it off and still be connected to your oxygen. I mean, it's crucial that you're pressurized. In my case, what I was doing is every day I was simulating a certain radiation scenario. So for example, from my research, I've been using the same code that NASA uses to calculate the doses for their own astronauts. So I developed a color coding system in which, for example, it's a red code, then it's really, really a bad solar storm, and if it's blue, you're okay. So I find that color codings is the easiest thing for people to understand. Give you a very basic example. When you go to the doctor and they give you a full body x-ray, you would receive the equivalent of 1 rem of radiation. And so that's okay, nothing's gonna happen to you, but you would most likely want to get one of those per year. And so for example, on Mars, the radiation doses are much higher than that, and it is not well understood yet what would the effects be on humans. I think it's going to be a mixture in between material research, so a new material that is going to be good for shielding, and biomedical research. I have a lot of faith in new drugs that are going to stop the radiation from causing its harms at the cellular level, but possibly repair it once it hit too. I've read a lot of research on that area, and I think it's very promising. I'm more optimistic because the doses that I saw were not so high in terms of day by day. And if you can have your habitat in a way isolated or protected or shielded in a way that you can assume you're okay inside of it, then I think it's not a major hazard. And that's a big concern. And there's a lot of study going on that. But I really, my conclusion was, unless you don't have a big solar storm, I think you're okay.